Hello, welcome everyone. Yeah, so it's 4 p.m. So it's the last presentation. I hope that you all finished your daily tasks at work. So now you are ready to listen to completely listen to at least one presentation, right? Without distractions from the background. This is what I was hoping to do during this conference. However, this time I didn't manage to do it so well. I will watch the streams later. So yeah, my name is Jacek Milewski, and I'm working at the Circle K, where we are doing, apart from the project, current projects, we are doing the IT stuff for the whole company, right? And this center, this business center, this IT center is located in Warsaw. So this is why I'm here. Probably you know the company itself. Um, well, you all fuel your cars, and some of you eat hot dogs and drink coffee. So probably you're familiar with our products. But coming back to the subject itself, I would tell about the things that happened in Circle K in one of the projects that I am responsible for. First, let's see what is the topic of the presentation. I want to focus your attention on one thing. This image is not readable on purpose because I would just want to show you that very often we focus on business logic and business validation, business rules to be valid, to be complete, in order to, just make money or do not lose money. So our system should behave properly to avoid money losses. And the business logic is very often pretty complex. We have a lot of rules and we care about those rules. We unit test them, we integration test them to make sure that they are working well. However, still, there's this one simple form in your application that very often has not enough attention, I think. When you're starting the Greenfield projects, probably in the first sprint, you set up your IDEs and the project itself. In a second, maybe you deliver some basic feature in the first sprint, and in the second sprint, you protect this basic feature with a login screen. Right, so a user has to be logged in order to perform some operations that are critical for our business. And yeah, so the login screen delivered in the second sprint stays as it is up until the end, right? Somewhere in a sixth, fifth sprint, maybe we do deliver, maybe we connect to some monitoring tools, alerting tools that we have in our company. And starting from that, every new critical feature will be monitored, alerted, and so on. But the login screen that was delivered before, still works because it's just a login screen. So we tend to forget to have a proper alerting or monitoring on it. And I just want to focus your attention here. Well, I'm a software developer. I'm not a security expert. However, I'm a software developer experienced with security incidents because of the login screen. So this is why I am presenting those findings that we had. Let's start with the facts. So that the reality we are in is not very friendly. We have, just by quick Googling, you can find a lot of articles about breaches, security issues. Probably you, maybe you follow some of good portals that, let's say, publishes such breaches. Let's start with the article on TechRadar that 44 million Microsoft users are guilty of credentials reuse. So that means that they have the same login and password in Microsoft as in some other services. Services like some forums, some gaming forums, or some, let's say, fisherman forum or anything. that are maybe not that well protected as Microsoft accounts. So we can trust that Microsoft protects its user well, but there are leaks from other services. And if you reuse the credentials from with more than one services, within the more than one service, then probably leak from one service will be used against you on the other service. And here Microsoft says that he scanned 3 billion leaked credentials from published, let's say, credential databases that have leaked from other services. They did the password reset for all those credentials that were reused, and well, they hoped that this time their users didn't set the credentials that were used elsewhere. Right. So let's hope that this time the user did it well. And again, TechRadar, you can notice the pattern if there is a blue-black color graphic in an article, then probably it's something scary, right? This time again, breach. So it says that 21 million credentials from Fortune 500 companies are breached. That means that as a Circle K, we are in Fortune 500 and we are actually somewhere around 200. Our position is around there. So we might be affected, right? So we are in the scope of interest for attackers. What do we see? That from those 21 million credentials, only around 5 million were fully unique passwords. So it's not that they leaked. It's about that just 25% of them were fully unique. Still, the story with the top 5 most popular passwords is in place, right? I hope that you can't find your password here. It's surprising to me that there is no QWERTY, but still, those are very simple passwords. What is alarming? Maybe for you also, but for me personally, we as a retail company might be affected with weak passwords. As in this article, author says that 47% of passwords are weak in the retail sector. Right, so I don't know, it is not specified what does it mean to have a weak password. But for us, we measured this number in our system, and for us, this number is very low. It doesn't reflect this value that is stated in this article, but still it happens, right? And yet another blue and black graphic. We have 620 million stolen accounts for sale on dark web. Yep. So the first thing that I've checked is how much. How much is it to buy such database? And let's say that your account is there, that your account is leaked and it's on sale. So how much do you have to pay to buy your account, to buy credentials that leaked? Well, in fact, it's $20,000 for the whole database. So buying one account is just a fraction of dollars. So it doesn't make sense to make a transfer at such low value. So you just transfer $1 and you get 31,000 accounts, right? So pretty nice deal. Still, those are leaked credentials. This is raw data. So we don't have a confirmation whether those credentials are being reused. Those passwords are weak or strong. We don't know it, but still, it's easy to buy, right? And it's even more easy to find such credentials. You don't have to open Tor, or you can just open the Pagehash.org. You could have done it around 2 months ago. Right now, the site is down because they had some corrupted database, some corrupted data in database, and that crashed them. However, well, on Hashes.org on the left side, you can see the services that leaked their data, whether it was by an attack or they have let's say, some breach in them, but this is the list of the services. And on the right-hand side, you see extract from this service, right? So here you can find on the left part of each row is a hash of the email or login, and on the right-hand side you can see the password. If you donate to Hashes.org, maybe they will be able to get up faster after they crash, and they will, in return, deliver you a list with unhashed login or email, right? So you get the full set of credentials. And the password, as you've seen from example surveys, are pretty simple sometimes. Like there is password 124, 124, not 123, so maybe not that simple. But still, Alexandra, yeah, then Alexandra 1. So basically the rules are the same, right? Users have weak passwords. So passwords is not a good protection of critical resources. And let's see what can be done. So 2FA, right? With this knowledge in my system, we introduced 2FA. However, we did some research before. We checked how popular 2FA is. And let's say that Office 365 has this feature to enable 2FA, right, to access those domains that are stored in the cloud. And it turns out that only 20% of companies are have this feature enabled, right? So this is not, some gaming forum or some Pudelek PL or anything. It's very serious cloud. There are very pretty important data there. So those PowerPoints for CEOs, those Excel files with salaries or with grants or anything, they are protected with reused passwords. Right. So the awareness is still low amongst the companies. However, amongst the users, I think that adoption is pretty high. So those are the numbers. For me, it means that adoption is high. I mean, 70% of young people do know what 2FA is and how to use it, have used it maybe at least once, and even over 30% of seniors, 65 plus, are aware what is 2FA. So adoption is pretty good. Maybe you know, maybe you don't know. You can check whether your password has leaked. So have I been pwned? You can enter your password and it will return you info whether this password is in some public leak. Or you can set an alarm. You can you can post your email and you will be notified whether when this email will appear in a public breach. But be careful with sites of this kind. There was this scam site once that asked you for both email, login and password. And it promised to tell you whether these credentials are safe or not. And it always returned that they are safe. And immediately after that, they use those credentials to log into several services because you just shared your credentials, right? So this social factor is still being exploited by attackers. So you might be wondering whether after this introduction, we will go a bit more deep into the technical things. So you might wonder whether this is about you. So you do have system in the internet. However, let's say that you can't imagine why would attacker would like to attack your system. You don't have credit cards data. An attacker wouldn't gain much data about the customer. So why? Also, maybe the service is small. Maybe you're just collecting some points in loyalty programs whatsoever. What the thing is that it is tempting to think that your system is not attractive for an attacker. And the reality is different. So the story in my case, the story of attacks, right? We've been attacked. So I just wanted to share how it looks like from the perspective of a system that is being attacked, and how attacks look like and how the protection looks like. So the attacks that happened in our case were brute force attacks. So there is this brute force, understood as the simplest one, where an attacker trying to guess the user's password simply takes his login and attempts every possible combination of letters and digits and special chars maybe, and try to guess passwords. The number of attempts to guess such password is very big compared to, let's say, the number of attempts after the account is being blocked. So after 6 invalid logins, let's say account is being blocked or frozen. So yeah, those kinds of attack probably won't happen because the requirements of special chars, uppercase, lowercase letters, are well good enough protection against them. However, there are also two other types of brute force attacks. There is credential stuffing, and after this, in my introduction, probably you figure out more or less what it is. So credential stuffing is using the credentials database that leaked, and an attacker simply loads this database into his scripts, and simply for each leaked credential pair, he tries to log in using the login API. Other type of attack is password spraying. So let's say the attacker chooses one email, let's say jacek@gmail.com, and he's trying top 5 most popular passwords, right? Like QWERTY or 12345. And he hopes that I'm using this user is using one of the most popular passwords. So let's say if he chooses to try top 5 passwords, then we have 5 attempts per account, 5 login attempts per account. On the other hand, if he's using credential stuffing, so he has one database that he bought, he has 1 attempt per account. So from the system that's being attacked, it's difficult to differentiate what kind of attacker is using. However, in most of the cases, it's credential stuffing. So yeah, how it happened. So first attack in our case was very basic. It was held from single IP address, and we suspect that it could be made from a laptop owned by an attacker. So without any botnet network, without any sophisticated infrastructure, we just notice a traffic spike on our metrics, right? Like significant spike. I mean, it was noticeable. However, we didn't have alerting or some sophisticated monitoring. By sophisticated, I mean good enough, at least good enough monitoring. So we just noticed the traffic, noticed the unusual traffic. The monitoring in general in app is pretty good. However, we missed the alerting, right? So we added alerting later. So we also weren't prepared to answer some specific questions, whether what attacker did after he breached an account, what did he do? Or maybe was it an attacker, or was it in fact a user that by chance logged into his account at the same time? So the basic reason was that we've been missing logs. So we needed to improve our logs to log more simply. But in the case of the first attack, since we weren't sure whether this account was breached or this was a user himself trying to log into his account, we just reported all those accounts as breached that were used during this time. But still, it was not that much accounts, but still it was far too much. I mean, the attacker for sure didn't breach all of those accounts. Some of this traffic simply was initiated by the user itself. And there are two clues, two things that we could have done better. I mean, we returned a bit too much data on login response, on login success. So here's my first advice to you. If you prepare a response to login success, do not include any additional user data there. We included there some not very sensitive data like first name or last name, just to say hello, Jacek, in the corner. But still, even if attacker didn't have a chance to log into the account that he breached, he still has this data that you returned in the response in his logs, right? So it's better to do, of course, it's less performant to do two requests, but it's better to do second request to get additional data and keep a login endpoint just to log in the user, not to return the data. In our case, also we have this kind of specific user account. I think that in every system there is this specific user account that, in our case, that was sending an SMS message to the user even on unsuccessful login. And we did send 20,000 of such SMSs because an attacker simply tried to log in, he failed, but the SMS was sent. You know, we had a cost to pay. We've had users that received an SMS, they were confused. So better to avoid it. Again, if there is some side effect, better to make it in a separate request. So this was everything about the first attack. So we did have some procedures. We knew how to act in the case of an attack. So yes, there was another. There was the next one, same type. I mean, still not distributed, but from distant location, from location that we do not make business in. So the locations could be India, Thailand, Indonesia, China, also Brazil, so very distant locations. The next type, yeah, it's time for distributed attack. Still, the same locations as before are dominating. However, there are much more other locations. We have this geo IP database, so they are not 100% accurate, but you know, it's a pretty good approximation of locations. So yeah, this time we've had exactly 500 attempts per each IP address. So we did add the rate limiting on our load balancer. However, again, attacker was pretty good as he limited the number of attempts per each IP. So rate limiter, you know, simply allowed those requests. And the most sophisticated attack, I think, that is the one that had one request per IP address, which is, you know, very sophisticated. I mean, maybe not sophisticated, however, pretty costly from an attacker perspective, because the botnet network that he had to lease, that he had to pay for, was pretty big in this case. However, all IP addresses were from just one country, unexpected one that we do not have traffic usually from. So it was easy to detect, and still he did very frequent attempts, a lot of very frequent attempts. So we had a traffic spike. Well, he paid a lot for this botnet network. However, he did not breach any account. So it doesn't always mean that if you buy a bigger network, then you will succeed, right? The clue is to have a good credentials database that you will train against the system being attacked. What you should observe, what do we observe in our case? Well, we watched basically two metrics. First is the count of unique IPs. Because most of the attacks are distributed, so we have a lot of IP addresses that are calling us. And the number of unique IP addresses is pretty good metric because you see spikes when some distributed network is calling you. The second metric is maybe more business, belongs more to business logic, is login to fail success ratio. So how many login fails do we have? Even more specific metric could be login fail caused by user not found, because an attacker buys a huge user database. And of course, not all of those users, unless you're Facebook, has an account in your system. So he tries several million of accounts, and let's say that you have just 5% of those accounts exist in your system. So you have a lot of errors, login errors, because of email not found, login not found, user not found. Of course, on login API, you do not expose why login failed. But in your logic inside your app, you know that it failed because the user was not found. And this is what you should log and alert on to note those unusual traffic and attacks. So we know that attacks are still improving. We are, let's say, forecasting some ideas that attackers might do to improve. The first thing is to do it slowly. Right? We do notice traffic spikes because they want to check their database fast because they pay for botnet network. If they do it more slowly, then maybe they will they will do it unnoticed because our alerting thresholds would not be hit. Or maybe they should do it faster so that our blocking rules will not have time to fire. Or maybe they should invest in better credential databases, right? They pay for botnets, bot networks. Maybe they should invest more in better databases. And still, we never know whether they are improving or we can detect more attacks because our monitoring or our tools are improving. And the worst thing of all is that we still might be under sophisticated attack and we are not able to detect it. So apart from the metrics and alerting that I've shown you, we've also introduced second factor authentication. So we're sending a one-time password to user's phone to confirm that this is him, not an attacker, right? Because we might have, imagine a case that an attacker picked one account and he's maliciously using this account. And so there for sure will not be traffic spike, but there will be a lot of harm done to this account. And alerting, so how do we know? What do we alert on and what do we monitor? So basically we watch two things. First of all, we are watching traffic spikes, and also we watch some kind of suspicious activity, both on metrics, but also on business processes. If some user is behaving not as a usual user, like for example, usual user, opens a web page. So first he downloads the web page, he, let's say, downloads some configuration. There are several requests, let's say, to open the web page, while an attacker is just calling from his script the login endpoint. So, the difference is noticeable. Right? The important thing is the analysis. Right? We will be attacked, and you will be attacked, and everyone is attacked. So we need to make an analysis easy. So once an attack happened, an attacker has a script that attacks you. So he will use it again. So the automation is a key, right? So we do automated the analysis. We fire the script and we get the results. How many accounts were broken? If there were any accounts broken, we also see that accounts that are misbehaving, they do not follow the usual patterns, and we also improve the tool. Right? We need to check whether the specificity of the attack changes. what we do is a short checklist, the shortest checklist possible. Maybe you could use it in your case also. We cut off the access to the user. So we force password reset for him. We check the activity that was done on this account, whether there were any data breaches, whether the attacker logged into an account, did some business operations, and so on. We report it as an incident, we inform users, and we take steps to prevent it in the future. So yeah, we try to detect an attacks and prevent them. We don't want to miss the precise attacks targeted against single account. It's whether it's easy to prevent than detect. We use both. However, I think that it's a bit easier to prevent it. For example, by strengthening login process by introducing 2FA. About the passwords, we checked. I've mentioned that in this article there was a message that 47% of credentials in retail are weak. Let's say what does it mean weak? So we checked it, how it looks in our system, and definitely 47% is far too much. Our values are much lower. We checked two things. We scanned our hashes of our customers' passwords against common passwords that are published on GitHub. You have a link below. The passwords that are QWERTY123, or the second thing that we did is we measured password strength or password entropy. So there is this pattern that we can replace O with 0 or A with 4, and your password is more secure. And that's not true, because an attacker also knows it. So if you replace O with 0 in word password, then still an attacker knows it, and he will also do the same. So we measured how much such replacements has to be done in order to guess our customer's password. Still, this number is very, very low. So our customers have secure password. So they do have secure password. However, they are reusing it, and this is the issue. So an attacker logged in, and what did he do? Actually, he did nothing. He did nothing. Maybe he didn't have time to watch at the report and to use those accounts because we blocked them, or maybe they are checking. Maybe we are not target. They are checking maybe the user's account, right? The leaked credentials database are pretty cheap, maybe, because those credentials are not confirmed. After they do confirm that some of those users, let's say 5 accounts out of 5 millions, are using the credentials, maybe they can sell those 5 accounts much more expensive than they bought. And with those 5 accounts, you can go to the bank and try them out, whether you can log in. Why they didn't attack us before? Why they don't attack your system still? Well, we have a new product. We had a new product announced on the TV, and we gave away 3 liters of fuel as a promotion, right? So this is pretty attractive for users and attackers. And also, we improved monitoring and alerting. So the most important question is to know whether you are attacked or not. You might be attacked, but you might not know it. So please take a big attention to your observability, to your monitoring and alerting. And here's the place where I planned a quiz, because I was preparing this presentation before those strange time that we're in. So, in stationary conference, you can raise your hands and guess. Because I'm going to show you now production metrics, and now you won't be able to vote whether you think that this is attack or not, but just look at it and think about it. I'm showing the production metrics. This is the moment where you have to ask your company whether you can do it. And yes, we can do it because we want to share data, also share the knowledge. Not many companies are doing it. So I just don't want to disclose too much, right? So the interesting thing on those metrics is traffic change, not actual values, but the change of value. So I'm hiding here the order of magnitude on value axis. Um, Also, the unit is hidden. You don't know what is the unit on the value axis. You don't know how much instances we have because the logs are just from single instance. We have more instances. You don't know what is the load balancing between those instances. However, you know everyone is using the same, but you don't know. You don't know what are the rate limiting rules, and the traffic presented is after the rate limiting applied. You don't know in some of the cases when did it happen. So here is the traffic spike that we have on a login endpoint. And the question is whether this indicates attacks. Taking a broader look, you see that this traffic pattern is being repeated every week. So are we attacked every week? No, we are being just queried every week. So it's a soft word for attack. So one of our customers has automated the process on their side. So they had a Selenium or any kind of automation framework, and they simply log into our account, to our system, and check some data and log out. Well, interesting thing is that even if they do it every week, even if they have it automated, they still have login failures, right? So they seem to be guessing their user passwords, even if they know that because they did guess it last week, but still they have login failures. Strange. So next attack. Here we have a traffic spike. At the zero level, let's say that is usual traffic, so we have a visible spike, pretty big. And we've investigated what emails are attacked, and it turns out that no emails were attacked because there was this placeholder in the login request, right? So there was email and enter value or placeholder or enter your email, and it turns out that CSV from credentials database didn't load for an attacker, but later he did manage to uh, to put those emails in the request. And the impact that he did finally after this second attempt was that he attacked from around 400 IP addresses, 16,000 requests, and 11,000 of those were stopped by rate limiter. So as a result, he tried 5,000 emails, and he did one attempt per account, which means that he had single database. It lasted 5 minutes. Not many accounts were breached. Another one, even bigger, shorter. However, the important thing is that he had around 100,000 requests, and just 300 were stopped by trade limiting, right? So he managed to trick our rate limiting pretty nice. The long one, the biggest one, and the longest one that I want to present you is, as you see, has lasted around 1.5 days. So here on the top, you see the chart from Grafana, and below from Kibana, where each color represents a country that issues a traffic against our login endpoint. So first we start here, and we have a spike around midnight from the purple country. At some point, we noticed that the attack is pretty effective, so we have a lot of accounts being breached. I mean, relatively a lot, but still not that much. So we started to block traffics for some countries: Thailand, Brazil, China, India. And you see that some colors dropped, but there are new colors, new countries that started attacking us. So the botnet network was pretty intelligent. We started to block them. We started to block yet another countries. And at some point, we noticed that it doesn't make sense. We, instead of blocking, we just whitelisted countries that we know that we want to allow traffic. There was still a traffic coming from those whitelisted countries up until then, when the attack ended. So it was pretty big one, right? There was 5,000 IP addresses and almost 2 million requests, right? 1.5 million emails have been tried, so pretty much. As a bonus, I would add that all emails that were attacked came from Danish domain. I mean, several domains, not just one domain. So when we have 1.5 million attacked emails and the Denmark population is somewhere below 6 million, then a big part of Denmark was attacked, right, in this case. Lessons learned: when we blacklisted and whitelisted country manually, then we decided to do it automatically, right? We have our metrics, we have our alerts, we have triggers, and on this trigger, we do enable blocking access control list ACL on firewall on AWS that blocks the traffic. And that one, again, we have countries marked in different colors, and we see that one country is leading. What's happening? This time it's marketing campaign. It's not an attack, it's just a marketing campaign. The marketing division from the company was good enough, kind enough to inform us upfront that they planned it. And one of the most interesting attacks is this one. Again, I've selected two countries with login failures. You see that there is green and brown country that have login failures, and there is a break, there is a pause. And on the chart below, you see login success from those two countries. You see that during this pause, there are 68 login success, and then login success has stopped, and again, we have login failures. What happened here? We do have an attack here for sure, and the email that had login success, we checked it, and it was an account created right before the attack. It's not the only case. We have several similar cases before. The email is from the domain based in some safe country, encrypt email accounts, things like that. However, to register an account, we do also require phone number, and we confirm this phone number with the SMS code. We know from which country. We know that this country requires prepaid cards to be registered. So actually, we know who was an attacker in this case. So how do we protect? How to stop it? I have a big slide with a lot of ideas. Maybe we can come back to it later. However, each of those ideas by itself doesn't help, but as a group, when those ideas are linked together they give good enough, I mean, very good protection against the attacks. So whose responsibility is to have a secure password? Maybe a secure system. Maybe I will leave this answer to you. Whether those are just the users that might be not aware, developers that are developing system, the security. I mean, it's a matter of culture, I think. So the culture says that you are all responsible, and the culture also shows in the company how the reaction is, what the reaction is in difficult situations, right? Whether you are cooperating and sharing things openly, or there are stressful situations. So to wrap up, maybe some advices from my side, just to summarize them. So the first thing is to not return more data than needed on a login endpoint. Keep it focused on logging user in. Also avoid side effects on login success, whether this is success or failure. Please observe your system and have first-class monitoring from the day one. Also, would be nice to have a mechanism to secure your accounts, the user accounts that were attacked. And as a side note, don't use the same credentials, especially in the cases on the sites that are not trustworthy. If you need to do it, then use 2FA there if they provide such feature. Okay, and the most important thing, please check it tomorrow. Think about it now or tomorrow. Are you being attacked? And the question, most important question is, do you know if you are attacked, if your system is attacked? So thank you now. Now is the time for questions. And I'm calling the studio, guys.